today's class. In this video, we're going to discuss about what is the phases of compiler, what are the different phases of compiler, how the source program is converted into a machine level language program. We're going to discuss here. So before in the last video, what we have discussed is about the two major tasks, that is analysis and synthesis. In analysis phase, what is happening is the source code is given to the analysis is converted into a intermediate code representation that given to the backend, that is a backend is synthesis phase. Intermediate code representation is converted into a mission level language code. That is a two different major tasks about this compilation. And then next we're going to discuss about what is the structures of compiler. The structure of compiler is nothing but the given source code is converted into different phases, and finally we are getting a target mission code. The scanner, that is a lexical phase. What is happening is the high level language program, source program, the C program or Java or Python is given to the lexical phase. Here the lexical phase, the program, the character stream converted into a tokens. The tokens is given to the parser. Next phase of compiler, in that parser what is happening is it will make a tree structure, hierarchical order. That parse tree is given to a semantic routines. In that semantic phase of compiler, what is happening is it checking the type checking, and then the type checking, after type checking is given to a optimizer. The intermediate representation of program is given to optimizer. In this optimizer, what we'll do is using people optimization, different optimization technique, we'll reduce the redundancy code and unuseful useless code and all. And then that after that optimization code is given to a code generator. What the code generator will do is it will convert to a target mission level language program. In the first phase of compiler, that is called as lexical analyzer. In that, what is happening is the each and every input characters, character by character, reading, grouping the character into individual words and symbols. It's converted into a tokens. Next to the token is given to the parse tree. The parse tree is reads the tokens, group the context-free grammar unit, a specified production of context-free grammar, and this syntactic structure is recognized. The parser either calls corresponding semantic routine directly or built as syntax. Example is context-free grammar. Next one is semantic routine. Here the main is the art of a computer. The type checking is involved in this. Check to static semantic of each constructor. And then the optimizer. In this optimizer, we are using a people optimization, looped optimization, register allocation, code scheduling is all done in the optimizer technique. After the optimizer, the code is generator. In the code generator, what is happening is the target mission level language code is generated. Example, generating a code for tree, DAG, grammar based code generation, and interpretative code generation. These are different techniques we are using in the code generator. The structure of the compiler, here the position equal to initial plus rate into 60 we have given as your input to that lexical scanner. Here the lexical analyzer, what is happening is it will convert each and every token into a separate value, and it's stored in the symbol table. We have a three identifier. One is position, second one is initial, third one is rate. It's given as identifier 1 is position, identifier 2 is initial, identifier 3 is rate. Is given to a parser. The parser with parse tree is generated according to the hierarchical value, and then the parse tree is given to a syntax semantic structure of that lexical analyzer. Third phase, in that we are doing a type checking. We are converting the value 60, we are multiplying with identifier 3, so we'll get a float value. For that reason, we are converting the integer into a real value. The 60 integer is converted to a floating value. Then that value is given, type checking is given to the intermediate code generator. The intermediate code is generated, that is a non-optimized intermediate code is generated. After that, we are giving to the optimization. That after that, people optimization, loop optimization, ratio allocation is done, and then we'll get a optimized intermediate code. After optimized intermediate code, we'll pass to the last session is code generator session. Here the 3 address mission code is generated for the given program problem. That line statement position we are storing in identifier 1. but and then initial we are storing identifier 2, rate we are storing identifier 3. So how it will be calculated is we are moving identifier 3 value to R2 ratio 2. The ratio 2 contains identifier 3 value and R2 contains 60, and now excuse me, R1 contains identifier 2 and R1 contains R2, and we are adding that R1 and R2 storing in R1. Finally we have the value of output in the R1 we are moving to identifier 1. These are the phases of compiler. There is a rule for the identifier rule, that is identifier can be maximum 6, length 6, no case sensitive. Identifier start with alphabet, uppercase, lowercase, and numbers 0 to 9. The first character can only be an alphabet. The keyword are not allowed to used in the identifier. No special character. Example: semicolon, colon, comma, white space, slash. Nothing is allowed. The special characters is allowed in the identifier rule. So only they started with alphabets, either uppercase or lowercase, both are allowed, and then zeros and nines. It should not start with 0 and 9 to 9. It can start with the alphabet. No special symbols are allowed. These are the identifier rule. So finally, what we have seen in this video lecture is what are the different phases of compiler: lexical phase and syntax phase, thematic phase, intermediate code generator phase, optimizer phase, and code generator phase. These are the different phases of compiler, and what is the rule to frame the identifier we have discussed. I hope you understand the session. Thank you for listening. We'll meet in the next video.